Imagine the smallest thing you can possibly think of. Now make it smaller. Keep going. You are still nowhere close. A Planck black hole is so unimaginably tiny that even if you lined up billions of them together, they would remain invisible to every microscope humanity has ever built. But despite its size, it burns at the highest temperature physically possible in the universe. Not the hottest star, not the hottest explosion. The absolute maximum temperature anything can ever reach. And then it vanishes. Almost instantly, before a photon of light could even cross a hydrogen atom, it stops existing entirely. Scientists are not even sure these black holes ever formed. But mathematics says they should, and mathematics has a terrifying habit of being right. Primordial black hole. The universe is 13.8 billion years old, and somewhere out there may exist black holes almost as old as time itself. Right after the Big Bang, before stars or planets existed, the universe was a chaotic ocean of pure energy. In some regions, that energy collapsed so violently that space itself folded inward, creating primordial black holes. Some may be smaller than atoms, others as heavy as mountains. The terrifying part? We cannot directly see them. They emit almost no light, consume almost nothing, and silently drift through space. One could be moving through our solar system right now, and we would have no idea. Kugelblitz. Every black hole you know formed from matter. Dead stars. Collapsing gas. Extreme pressure. But a Kugelblitz is different. It is a black hole made entirely of light. Einstein showed that energy and mass are equivalent. So if you compress enough light into a tiny space, gravity becomes strong enough to create a black hole. No matter required. Just photons collapsing space-time itself. Nobody has ever created one. The energy needed is beyond anything humanity can produce. But the universe operates on scales far beyond human imagination. Somewhere out there, conditions may already exist. Micro black hole. In 2008, many people genuinely feared the Large Hadron Collider might create a black hole and destroy Earth. Scientists were not worried, because cosmic rays hit Earth every day with energies far greater than the LHC can produce. If micro black holes were dangerous, Earth would have disappeared billions of years ago. Any microscopic black hole formed in particle collisions would evaporate almost instantly through Hawking radiation. Smaller than a proton, gone in less than a blink. The world survived. But larger black holes are a very different story. Stellar black hole. Right now, somewhere in our galaxy, a massive star is dying. For millions of years, it fought gravity using nuclear fusion. But eventually, fusion reaches iron, and iron cannot produce energy. The outward pressure collapses. In less than a second, a core the size of Earth compresses into something the size of a city. The outer layers explode outward in a supernova. What remains is a stellar black hole. Multiple suns' worth of mass crushed into a region smaller than a city. Gravity so intense that space itself falls inward faster than light can escape. Anything crossing that boundary is no longer part of our universe. X-ray binary, black hole. A lone black hole is almost invisible. But give it a nearby star, and it becomes one of the brightest objects in the galaxy. The black hole slowly steals gas from its companion star. That gas spirals inward, forming a disk of superheated plasma millions of degrees hot. The result is a violent storm of X-rays detectable across thousands of light years. Systems like these are called X-ray binaries. The famous Cygnus X1 has been feeding on its companion star for millions of years, and the star is slowly losing. Rogue black hole. Sometimes supernova explosions are uneven. When that happens, the newborn black hole gets violently kicked across the galaxy. No star, no light, no warning. These rogue black holes drift invisibly through the Milky Way at enormous speeds. Scientists believe there may be hundreds of millions of them wandering silently through our galaxy right now. We only detect them when they briefly bend starlight through gravity before vanishing back into darkness. Binary black hole. Sometimes two black holes find each other. They lock into orbit and begin spiraling inward over millions of years, releasing gravitational waves through space-time itself. As they get closer, they spin faster and faster until finally they collide. The explosion releases more energy in a fraction of a second than all the stars in the observable universe combined. In 2015, humanity detected this for the first time. Tiny ripples in space from a collision 1.3 billion light-years away. And somehow, our instruments were sensitive enough to feel it. Intermediate black hole. For decades, scientists only knew of two sizes of black holes, stellar and supermassive. But something was missing in between. Intermediate black holes fill that gap. They contain thousands to hundreds of thousands of solar masses and likely form through repeated black hole mergers inside dense star clusters. Rare, elusive, possibly the seeds of even larger giants. Supermassive black hole. Every human who has ever lived has spent their entire life orbiting a black hole. At the center of the Milky Way sits Sagittarius A star, containing 4 million suns worth of mass. Our solar system circles it at over 200 kilometers per second. One orbit takes 230 million years. In 2022, scientists captured the first direct image of it, a glowing ring surrounding perfect darkness. We photographed the monster we have orbited our entire existence. Quasar. A quiet, supermassive black hole is terrifying enough. But feed it enough gas and it transforms into the brightest object in the universe. This is a quasar. The infalling material heats into a disk so bright it can outshine entire galaxies. Some quasars consume the equivalent of thousands of suns every year. They do not just eat matter. They reshape galaxies themselves. Blazar quasars fire massive jets of plasma from their poles at nearly light speed. Usually those jets point elsewhere. But if one aims directly at Earth, it becomes a blazar. The radiation would hit us before we even understood what we were seeing. Ozone destruction, ecosystem collapse, global extinction. And the worst part? We would get almost no warning. Ultramassive black hole. Some black holes became too large for the word supermassive. TON 618 contains tens of billions of solar masses. Its event horizon alone is larger than our solar system several times over. If it replaced our sun, every planet would already be inside the black hole before reaching the edge. These are not merely objects anymore. They are gravitational structures shaping entire galaxies. Slab. Stupendously large black hole. This one remains hypothetical. But physics does not forbid it. A slab could exceed 100 trillion solar masses. Its event horizon might span distances larger than galaxy clusters themselves. Light entering one side could take longer than the age of the universe to cross to the other. At that point, it stops feeling like an object. It becomes a feature of reality itself. Naked singularity. Every black hole hides a singularity, a point where density becomes infinite and physics completely breaks down. Normally, the event horizon hides it forever. But some equations suggest that if a black hole spins fast enough, the event horizon could disappear entirely, exposing the singularity to the universe. A naked singularity, a place where the laws of physics openly fail. Most physicists believe something prevents them from existing, but nobody has ever proven that for certain, which means somewhere out there, reality itself may already be broken.